Welcome, and thank you for joining today's webinar, The Future is Composable, a guide for future-proofing your operations in life sciences. My name is Jenna, and I'll be your moderator for today's session. And now I'm excited to introduce our speakers for today's session. First, Dr. Gilad Langer, Industry Practice Lead at Tulip. Dr. Langer is an accomplished business leader with over 28 years of experience in digital transformation, manufacturing IT, engineering services delivery, and technical operations. He has a deep domain expertise in digital technologies and manufacturing business systems. He has an accomplished track record of digital transformation to drive high levels of operational performance in the pharma, biotech, and med device industries. He has also served as a trusted advisor and business consultant in those areas. Next, Daniel R. Matlis, President and founder of Excendia Inc., a life sciences analyst firm specializing in business, technology, and regulatory insights for executives. Since 2014, he has been a key contributor to the FDA's Case for Quality initiative and has served on the FDA's Advisory Council on Modeling and Simulation. He also provided input on the computer software assurance for production and quality system software guidance. Dan began his career at Johnson & Johnson and later became a partner, VP, and general manager at a prominent consultancy before founding Excendia. Named the top 20 life sciences influencer in 2021, he holds a BS in electrical engineering from NYU and an MS in management from NJIT. Without further ado, I'll hand the mic over to our speakers. Please enjoy today's session.
Thank you, Jenna, and welcome everybody to this webinar. I'm excited here to have Dan join me in another one of these webinars where we talk about composability. But let's just start by going over the agenda for today. We have 5 topics we're going to talk about. So we're going to start laying the foundation with what's going on in life sciences, the shift to composability, which is part of digital transformation. And then, we introduce composability, and I'll spend some time explaining what it is. We call it demystifying it, but really understand the core principles. We'll move on to talk about why it's advanced, why do we even want it, and why is it giving us any benefit. Give some success stories and idea or examples from the industry, how it's going, and then introduce Tulip's Composable MES for pharma, which is an exemplification of composability. So with that, I'm going to take us on to the next session and give it to Dan to talk about the shift in life sciences manufacturing. Dan, go ahead.
Thanks, Gilad, and thanks to you and to Tulip for the opportunity to share our insights today, and thanks for everybody in the audience for joining us. This is our safe harbor statement. Any content that we're going to share today is based on our primary quantitative and qualitative research, our interactions with regulatory officials, industry executives, and our clients. So let's talk a little bit about what is driving our industry. One of the key drivers that we're seeing across all products, whether it's pharmaceutical, medical device, diagnostics, biotech, cell gene therapies, is increasing price pressures on our industry. And this is happening globally. So how can we address this? There are a number of ways that we can drive this issue. One is around accelerating time to market. If we can get our products to market sooner, we'll be on patent longer. And while the prices may be lower, you can make that up on volume. There's opportunities to do that using digital transformation. We also need to improve process efficiency and, more importantly, effectiveness. As an industry, we really have struggled at becoming as effective as possible. As a result of traditionally very healthy profit margins, we've been able to throw people at problems and try to address them after the fact. And what we need to do is increase that efficiency and that effectiveness in order to protect profit margins. And finally, we need to adopt technology more quickly and have more accelerated time to value. Historically, as an industry, it's taken us very long to implement new technologies. And even when we have implemented new technologies, they're implemented in pockets or in pilots or in a particular plant or a particular site. And as a result of that, we're not gaining the value across the organization. And the time to gain that value is really, really extended. So in the next slide, we talk about the fact that we need to get on the right side of the digital divide, right? Today, as an industry, yes, we have implemented AI and in advanced technologies, and we're leveraging quantum computing in some cases, but the use cases are very small. If we look holistically across our organizations, across all of our sites around the world, we still have a lot of legacy and point solutions. Our processes are manual, and in many cases, still paper-based. They're outdated and disconnected, and as a result, they're very inefficient and cumbersome. And we really focus on documents and compliance. Where we need to go is to really implement modern cloud architectures and have unified processes and data across the organization so we can get visibility. The platforms that we choose need to enable us to integrate and expand so that we can become more effective and frictionless and really drive intelligence out of our solutions so that we can be outcomes and quality focused. So let me share some data points on that. We recently did a research study where we asked industry executives and practitioners, what is the impact of adopting advanced manufacturing technologies? And as you can see, 95% of respondents told us that it's going to be somewhat or very positive. So we see the value in adopting those technologies, but we're still slow on the adoption. When we ask, what are the goals? Why are you looking to digitally transform manufacturing? We were very pleasantly surprised to see that the primary drivers or the goals are around data-driven intelligence-based decisions, followed by enhanced manufacturing efficiency and throughput and yield, and then improve product quality. So this aligns very much with what we need to do. When we also ask what are the top capabilities in an ideal digital manufacturing solution, you can see that ease of implementation into and integrating into the existing digital ecosystem is critical. Nobody is going to rip and replace everything they have. So integration is very important. Having a centralized platform for data and applications is key. And then something that can be tailored to meet your needs, because one size doesn't fit all. It's just like a car. There is no ideal car. There is an ideal car for you based on your intended use for that car. And that becomes increasingly important. So really what we're proposing is to have something that is digitally sustainable. That's the term that we use, where it's based on industry standards, is effective and frictionless. It enables you to leverage a digital fabric, and then it's highly configurable, resilient, and has those unified processes. The other important thing is that we need to remember that traditional MEF implementations have been very difficult, expensive, inflexible, time-consuming, and really heavily process-centric. And what companies are looking for now are solutions that enable them to meet their needs and to address where they are today. So with that in mind, Gilad, how does Tulip define composability, and how can he address the industry challenges that we face?
Yeah. So thank you for a good introduction to all of this. And I think you mentioned a few important things. You mentioned, your analogy with vehicles or with cars. It's not news to anybody that a manufacturing shop floor is unique and dynamic. Everybody does things their own way different. In fact, it's in it's inherently within lean and operational excellence is to drive improvements in a way that fit the actual layout, the actual shop floor that you're dealing with. So this is only going to get, I won't say worse, but it's going to get more. It's going to accelerate. We need to not only adapt to the fact that it's unique and dynamic, but it's going to become even more dynamic. So that's the one aspect I think that you brought up that is super important, that every shop floor is different. That's how way you call it. The other you talked about was human-centric, and I want to bring in a quote from Daniele Covelli, who presented at our Ops Calling, presented the keynote at Ops Calling. And he said that, digital transformation, it has to be adapted to the business and the people, augmentation of people. So we're bringing in the human aspect of it, which is an important thing. Is in the digital age, we become more productive because we support human activity. We make humans do their work better. And, we need to accept and use this, the opposite being, very process centric. And then bringing it all together, a realization really that the old way of doing things, which we coin as monolithic, is a constraint, is a hindrance to achieving the real value that comes from digital technologies, or adapting to the digital age. At the end of the day, the reason why we want digital is because it promises an order of magnitude productivity increase. And if we keep doing things the way we did them, we are not going to get that increased. That is why we're introducing this notion of composability. And what we try to do with composability is give a framework for what is and is not digital, and what is and is not going to give you the order of magnitude productivity increase that you're looking for. So it's a very, very important concept to understand, and also a set of a framework that you can use as a business to evaluate, to judge whether you're moving in the right direction. So let's take a deeper dive into what is composability, demystify composability. Let's, I just want to start with, composability is a term. It was coined, as part of the industry. It's not so much, we can call it something else. We use composability, but really try to understand what it means more than the actual term composability. That's, I think, the key of it. Starting with understanding the differences between the old and the new. It being a paradigm shift, meaning that what we did before is not the same what we're going to do now. We need to understand that. In the monolithic age, we were very much thinking about functional hierarchies. That was, back in the 80s and 90s, the way to think about systems. We're moved into the age of edge and cloud. And so that's a very, very different structural, both in terms of how you structure your software, but also in how you structure the work around these technologies. The next is this notion of top-down versus emergent, both control and implementation of systems. Traditional systems, you do top-down. You sit and get all requirements. You figure out what needs, you break it in this. This is systems theory. You break it down. Also, the control of a plant is top-down. In the new technologies, we talk about emergent control, network dynamics. We build things bottoms up. We start small and build up. This aligns very much also with lean. And then lastly, as Dan mentioned, process-centric versus human-centric. I think, it's a very, very important aspect of looking at new technologies. And in a way, these three, at a high level, give you a guideline to judge whether technology is new or old. But I'm going to take this as the base concept, but let's take it into the principles of composability, okay? And this is our model, or a framework, or reference model, if you will, to say what is how and how we do. And it's built on a number of, you will probably also recognize a bit of the Pharma 4.0 operating model here, with the connectivity and digital maturity kind of as the basis of the composability concept. We will not get into that. In fact, if you're interested, those are very well defined in a lot of the literature around Pharma 4.0. The specific, the baseline guide as well provides some good references there. I'm going to focus on the pillars of composability. There are 5 of them. They're the ones in the middle here, starting with bottoms up. Bottom up. Digital solutions emerge from the bottom up. They're not going to be they're not going to come top down. So if you're in your organization thinking, we're going to sit in a room and figure out how we're going to implement this technology and then roll it out across our plant top down, whereas me, if I'm a person in a plant, I am going to get this magical technology, ushered upon me from some corporate function. That is not how digital technology is implemented. It actually starts bottoms up. You go to a problem and you solve it. You introduce it in small bites, and it grows. So we need to go to the problem and introduce the technology at the problem, and that's really where we start. So that's pillar number one: bottom up versus top down. Agility is taking that and saying, okay, how do we apply lean and operational excellence in manufacturing? Lean, operational excellence, things that stem from the Toyota production system, and trying to run a plant more optimal is at the core. It's how we run manufacturing. It's never going to get old. It's never going away. It transcends all the technological paradigms. So any kind of digital technology that does not inherently align, adopt, enhance lean or operational excellence is not going to do it for us. It's not going to bring us the productivity gain that we need. So starting from the bottom and applying lean principles, we call it augmented lean, bring digital in. Then comes the next pillar of democratization. Democratization means that to Dan's point in the services, it has to be easy to use. It has to be easy to adopt. Democratization is essentially that. It means it takes technology that was once complicated, complex, required a very high level of skills, and makes it everybody's technology. That is what democratization is. We talk also about citizen development. Citizen development is one aspect of democratization, but it doesn't have to be. Democratization is a bigger concept. It's about making technology available to the masses and letting everybody use it. Again, very key and important principle. And you can ask a very simple question: how fast is it going to take me to learn and start using this technology with zero skills? If the answer is not in hours or days and weeks, again, you're talking about old traditional monolithic technology. Lastly, human-centric. Or not lastly, one before last, sorry, human-centric. It has to support the human in what it does. And human-centric doesn't mean great UIs. It means that the technology needs to make the operator, the frontline operator, more productive. That's the core principle here, because that is where productivity comes from. It's by focusing on the humans and what they do and making them work better, more intelligently, more optimally, being more productive. That is what human-centric is. And again, if you have to sit your operator in front of a screen and take him to 2 days training on how to use the screen and have him align and adjust his processes to what the screen wants him to do, you don't have human-centric technology. And lastly, compliance, which is actually a very big pillar that we're going to touch lightly in this webinar, is that we need to bring in practices that make compliance inherent in the technology that we bring. This really is where validation 4.0 comes in, and some of the principles around validation 4.0. This is a topic that probably needs a whole webinar series by itself. We're doing a lot of work there. ISP, as part of Pharma 4.0, is doing a lot of work. This week, we also had our Pharma 4.0 conference in Rome. The validation 4.0 topic is being addressed there as well. And there's going to be a baseline guide, a good practice guide coming out around validation 4.0 in the beginning of next year. So plenty of content there. So that puts in perspective, the five pillars of composability. Once you do that, we introduce cloud and edge. And once we do this also correctly, we can start introducing some of the cognitive aspects, the AI and ML aspects of the technology in this. So just want to mention, edge, cloud, and AI ML, they are in a way synergetic or accelerators to this composability, but you cannot get there before you adopt the composability principle.
And I think, Gilad, if I can just add something that you mentioned that's very important, is the underlying technology actually dictates whether or not you can do this, right? If you have a solution that is still a 2-tier or 3-tier architecture, or even a web-based solution, you cannot meet these requirements because the technology won't allow you to do it. So
correct. And that's exactly what I'm saying. It's like you actually use it to judge whether you have the right technology choices made in your company. And again, it's not to say that you have to completely disqualify anything that you have that's monolithic. We are going to have to live with some of the monolithic structures we have in place, but when you understand where you need to go, it's easier to start to make decisions about what's right and not, or what's more beneficial for my business. So if we put this in what it means rapid time to value, right? So another way to look at monolithic versus composable is how fast does it take you to get to some value on the shop floor? In these diagrams, what's important to notice is the time scale. The time scale on monolithic is in years, as shown here. The time scale in composable is actually days and weeks. And that's also a very simple way to judge or evaluate if you're doing the right thing. If you have sitting in a room for 6 months playing with technologies, even technologies that would you consider composable, if you're sitting there in 6 months and you haven't got anything, you're not doing it the right way. You should be looking, 4 to 6 weeks and saying, I have something in my production showing me value, collecting me data, and I can use that, something I can use to improve. That's a key a way to evaluate new technology versus old. Okay, so what does it mean? What are the true advantages here for our companies? Dan, please.
Yeah, so one of the key questions that we always get is, well, how do we move into this new paradigm? We don't have enough data. And the issue is not that we have a shortage of data. We have petabytes and yottabytes of data gathering digital dust or physical dust in some old iron mines, right? The challenge is, how do you get value out of your data? In the next slide, we have a quote from Commissioner Califf, who said that by themselves, data are meaningless, right? It's only when you add critical context that they become information. And then once you have that information and you start analyzing it and combining it, that it can yield evidence that you can then turn into, that you can then use to guide your decision-making process. So that's the challenge. The challenge is not that we don't have enough. The challenge is that as an industry, we suffer from something that we call drip. We are very data rich, but we are intelligence poor, because we gather data simply because we can, and then we forget where it is, what we can do with it, or it's in some ancient system like paper that doesn't allow us to gain value. So instead, what we need to do is actually build these digital threads and look holistically across the entire product lifecycle, right? We need to weave these digital threads into a data fabric that gives us visibility, but ultimately it's this digital fabric or digital twin that enables us to gain visibility all the way across the entire product lifecycle, from raw material to patient, and from the shop floor to the top floor. Because ultimately, this data, as one client told us, that the data doesn't belong to a department, it doesn't belong to a system, it belongs to the product, right? It's the product's data. And we need to be able to view it holistically in order to make the appropriate decisions so that they're intelligence-based. So with that in mind, Gilad, how do you look at building digital twins in a composable environment?
Yeah. So we need to get to this concept of digital twin, but I want to kind of go back to what you said about drips. We have a lot of data, and data is spread. I think in our industry we still have to be we have to be real with ourselves. There's still a lot of paper out there. Yeah, that's kind of one thing to address. I said this multiple times, and I think we even said it in other webinars, right? Definitely number one is digitize your paper. We need the data to at least be digital so we can start using it. But then mine is, when we talk about data in the digital world, obviously that's a core. digital is so powerful because we have data about everything. And we use that data to become smarter, to get insights. But we also need to understand how we interpret the data. And that's where this digital concept of a digital twin comes in. Digital twin, is many things. And again, there's great debate and a lot of concepts around it. But the reason why it's good is because it makes it interpretable for humans.
Mm-hmm.
We're seeing digitally what we typically want to see in the reality. So when you take a human and say what you regularly see when you use your eyes to look at the real world, when you switch over and look at your screen, you're actually seeing the same thing. That means that there's no interpretation or abstraction. That's what we want to get to. That's, in a way, it's a high level to define digital twin. The other way to define digital twin is by outcomes, like what is it going to give me? So when we start talking about representing data in a composable architecture, in a composable solution, we have to adopt a simple method that, again, helps us represent the reality of our shop floor in the tool itself. One way to do that is, and you've seen that many times, is these 3D models that literally look like your factory. Great. But in a shop floor, NES type or kind of operational system, that's not very beneficial. Great, I can see the visual of my plant, but I need to go one level deeper. To that, we introduce in composability a very simple artifact model. We call it an artifact model to say that if you, in your solution, use tabular data, what was once would be maybe even a database table, but let's just call it a tab in a spreadsheet. If we use that to represent only physical and operational artifacts, meaning that when I go into my data and I look at a tab in my spreadsheet, I can immediately recognize what that tab is. A physical artifact is an equipment, a room, an area. An operational artifact is a work order, a defect, a deviation. Those are true things that, regardless of digital technology, I have in the reality of my shop floor. So when I walk into my digital system, I should see exactly the same artifact. Those are called physical artifacts. The processes, the activities, the workflow, all that abstraction of what goes on the shop floor, that needs to be represented by apps. In the Tulip world, we call them apps, but that is the digital content. And apps really look like PowerPoints. So if I have a spreadsheet that each tab represents one of my real physical artifacts and operational artifacts, and then I have apps that represent what I do on these artifacts, literally slide by slide what I do, anybody can walk into the system with no knowledge of the system and immediately interpret what's going on, both how you do things and then looking at the data that was collected because it reflects that way. That is not only immensely powerful for people who are building the system, of course, but the whole facility. Think about your plant manager who doesn't know anything about this. When he sees data that way, take it one step further. Bring an auditor into the room and say, this is how we do things. You open up the core, the guts of your system, and you're showing an auditor. Why? Because it's a one-to-one representation of the reality of your shop floor. And so that becomes immensely powerful. And we have examples of our customers bringing auditors, opening up Tulip to the auditors 100% and just showing them what they're doing. Very, very good feedback on that. So it does work. Let's talk a bit about, that was a good segue anyways to some success stories. Starting with a case of Next Pharma. Next Pharma is a CMO in Europe. It's a great story of application of composability. I am just going to take you to the bottom line here, the outcomes. Validated MES in 9 months, which was, this happened more than 2 years ago. We are, in fact, doing this much faster right now, and I'll talk about the next use case. But that gives you an indication of how fast you can get a full-end, compliance system with validated in a shop floor. And in fact, their solution is pretty advanced in how they use, because they not only do they use the core of the platform, it's connected with our edge devices. So it's bringing this notion of cyber physical into the mix. So operator is surprising, because when you think about a compliance validation perspective of validating this if you will, a complex system of cyber physical, into one, and doing it that fast and getting value that fast, is an incredible story. So that is one of them, and then taking it into another case study that unfortunately we don't have permission to share the company name here. But in this case, I'm going to take you again to the bottom line here. eDHR solution in 3.5 months. And this is an incredible feat, meaning that from hitting the ground at the site and starting to work on designing an app to being able to have the first app on the floor validated in production in 3.5 months. So this is an exemplification of what I started with about composability. Once you truly adopt this across the board, the pillars, obviously compliance here, an important aspect of that, you can start getting value. And look at the savings here. So, if you say what the alternative was, implementing a traditional monolithic system, and again, this is a full end-to-end eDHR with a integrated supply chain. So both the formulation, so all the way from formulation, application into aseptic packaging and double packaging and multiple variants. If you do that in a traditional system, we're talking years and millions of dollars. Another very interesting outcome of this, and this brings out kind of not only the human aspect of it, but also what it means to people. The turnover at that site went from 20% to 0, meaning that this site usually was the operators would turn on 2 out of 10 operators within a few months would have to be replaced. Once we introduced the system, it became so interesting that for the operators and the engineers that they didn't leave their job. This has become a job that is more fulfilling, a job that promotes their career. And so there is value in digitization across the board in many, many things. Because we brought in IT and OT, so bringing in the merge of OT and IT, because it went so quick, and we actually introduced these 1-week agile sprints of building an app, putting it on the floor, getting feedback, and putting it on the floor, and brought everybody together. And I brought people together, introduced a much stronger culture of continuous improvement and bottoms up around these things. So this is like an implication of digitalization at its best. So it's not only the technology, but what it means to the culture and the business. Productivity increase, culture gets better. So if you do this right, there's a lot of benefits. I'm going to end up here with introducing our Composable MES. So one of the things that we've done is we've taken composability and brought it into our library in a set of tools and apps and templates that allow you as a customer to go to the library and we said 3.5 months from 0 to this. That is without this content. If now we could use its content, we can probably reduce that even more. So this is this composable MES. In a way, we use the term MES, but think about it a composable solution specifically for life sciences, where you can start with templates that not only have a lot of the good content and the kind of the common functionality that you need, but also has embedded within it these composability pillars as a starting point for you to introduce or start your digital transformation in your facility. Specifically, this is for pharma. I think that is probably the last slide that we have. I don't know, Dan, if I went on a bit of a thread here. If you had anything to add before we open up for questions.
No, I think just to emphasize what you mentioned, it's really around bringing, making it so that the operators can run the process quickly, efficiently, effectively, so that you can get improved productivity. I think that's one of the key values that you need to look for.
Thank you both very much. Great insights. We are about to kick off our live Q&A. So to kick us off, our first is, what do you think is the best way to successfully deploy a democratization strategy for a composable MES?
Yeah, so great question from Edgar. So it's actually, so democratization is many things, right? A key way to introduce democratization is to use tools that help you do that. No code being one of these things. So this concept of low code, no code is taking industry by storm. So not even within manufacturing, but across the board, low code, no code is changing the way we operate in many different industry verticals. So that was kind of a long-winded answer. No code, low code is one way to introduce democratization, but there are other tools that make it easy for people to use technology. So that in itself is you need to align your strategy around the low code, no code, and I think many of our companies do that. But then behind that, of course, is edge and cloud and many of the other things that are out there in the industry. You want anything to add, Dan?
Yeah, so we also look at it from a data availability standpoint, right? Part of the democratization is making sure that the people who need to make the decisions have the insights and the intelligence that they need in order to make those decisions. In the past, you used to have to go to Jane or Joe or go into this particular system to get that type of an answer. And that made the process very inefficient and ineffective. So you're talking about it from a usability standpoint, but you also need to think about it from a decision-making standpoint. How do we make sure that the people that need to make the decisions can make the right decisions based on the appropriate insights? And also in many cases, what we see is companies look and hire data scientists who are going to then figure out what's the right way. But that becomes also part of the old way. You need to go to the data scientist in order to make something happen. So democratizing the availability of not only the data, but again, the information, the insight, so that you can turn it into intelligence. It's a really key point to driving a strategy, whether it's but also across the organization.
And ultimately, so if you think about it, the whole generative AI with the GPT is kind of it's democratization on steroids.
Yes,
That's really what it is. So you chat with your data. So no longer do you need any of that. So I think we're going to see generative AI come in and taking this democratization to a whole other level. In fact, we're also introducing in our upcoming releases with generative AI, the ability to create analytics, for example. So instead of you defining what you want to see in your pivot table, you simply ask the system, draw me a bar graph of my defect Pareto. In fact, even taking it further and saying, create an app, build me an app that manages my defect, manages my deviation. So taking democratization even more broader.
Awesome. Thank you. Next question is, how do I know if my company is ready for composable technology? Do you recommend a technology first or a culture first approach?
So I'll start with Peter Drucker said, culture eats strategy for breakfast, lunch, dinner. Never start with technology. Technology is an enabler that will facilitate your transformation, right? But what's really important is if you can have the best technology, but if your culture doesn't support it, if people in middle management are putting sticks in the wheels of the implementation, then you're never going to be successful. So it's really important to get buy-in across the entire organization on the need to transform and then implement technology. And to Gilad's point earlier, you need to implement technologies that will show value quickly, right? If I have to wait 1.5 years to show that this new technology is going to work, adoption is not going to happen. So Gilad, what are your thoughts?
Yeah. So I love the quote, of course. Yeah. So this if you think about the barrier is culture, and skepticism and unknown. And it comes from risk. It comes from people's not understanding what it is. And I think that's the biggest barrier. And I deal with this daily. It's the barrier is, do we even have something that's different? I mean, I think one of the things that that still astounds me is that, we live in this world that's becoming so digital. But when you walk into the plant, we're like walking back, 100 years.
Yes.
It's still, no, when I drive my Tesla to work and all the gadgetry, but when I walk into a plant, it's all paper. And I'm okay with that. And so there's nothing new here. That I think is I don't think it's that prevalent anymore, but there's still that bit of culture, and we have to deal with it. So we have to open it up to the leaders in the operations to say, like, there is an opportunity here. There's a new world coming, and we need to embrace it. And we embrace it through change management in the same way that we do lean. And that's another important aspect of why composability is an enabler here, because pillar number 2, as I said, agility, it actually ties in and says technology and lean. Like, lean is established. You can't argue that lean is not a thing in manufacturing. So, if you bring down technology that aligns with lean, it actually is an easier way to introduce the change into your plant, into your factory.
Yep.
Wonderful. Next question we have is, in my field, every project that passes through the individual stations is completely custom. Can Tulip be configured to be individual product/project based versus station based?
Yep. It's very, so Brand clearly conveyed, and it's a common use case. And it's not that as unique as you make it, actually. It's actually, and it's becoming even more. So there's an engineered order, a configured order, and kind of what I call it, backsides of one. Many industries that have that. So everything is specific. And yes, Tulip, in fact, Tulip is a very powerful tool for that. Again, this is it's one of these examples that I use a lot in composability, right? When you think about monolithic, you're trying to create a data model that adapts for everything, all the scenarios. When you use Tulip, you can have a specific app for every specific project. And then you say, well, okay, that means I have to rebuild an app every time something comes through. No. What you do is you kind of use a traditional kind of PowerPoint mentality. I have a template. It's nearly there, 80% there. And every time I have a new small change to something, I add a step. I go into my app, I add a step, and that step can also be a copy of another step, meaning that you can have step templates. You change a few things, you publish your app. It probably doesn't take you more than a few minutes or half an hour to do. And you can actually have a manufacturing shop floor that, as a new order comes in and gets engineered, it actually creates a whole set of apps for that order that were based on templates, and then you start running on it. And that app may only run once in that version. And the data that it collects shows, when you look at your data, it actually shows you that. It says, oh, the data for this specific order actually ran this app with this name, with this version. And if you look at the data, only ran once, but you have that, it's all in the context. You know exactly what it did. And we would be happy to show you how this works. We actually have customers that do this. Bang.
Awesome. Next question. In the past, regulators were not comfortable with the use of new technologies. Are regulators now accepting the use of advanced manufacturing? How do I think about validation?
Yep. So I'll take this. This is a topic that's near and dear to my heart. When I worked at J&J, I helped develop the original computer system validation processes and procedures when the quality system regulations were updated and before the new guidance or the old guidance was issued. But the challenge is, as we talked about earlier, at the time, the technology was not mature. The vendors didn't understand what this whole validation process meant. It was new to us. It was new to them. So we instituted, as an industry, very rigorous processes for validation. And the regulators were concerned. Yes, they wanted us to adopt electronic records and electronic signatures and automate manufacturing and quality systems, but they were also concerned because none of us knew how to do it. So the standards were very rigid. Over the last 10 years, the regulators have recognized the value of adopting modern technology. The fact that when you're automating, you're actually lowering the risk, because when a human does it, you have human variability. When a computer does it, when a system does it, and you can have assurance that it will do it consistently, it actually lowers that threshold. So that's where the whole dimension around computer software assurance comes into play. There's a number of initiatives that have been going on. FDA has funded through MDIC, the Medical Device Innovation Consortium, and a private-public partnership, a number of projects to implement modern technologies within manufacturers. You have FRAME, which is the FDA's framework for regulatory advanced manufacturing, actually driving the adoption of technologies like artificial intelligence. And then there's advanced manufacturing research frameworks where the FDA actually has in its facilities advanced manufacturing technologies that it is looking at and evaluating and actually encouraging companies in our industry to adopt. So definitely the regulators are ready. They're not only ready, they're encouraging and incentivizing us to do it. And even if you look at the current guidance that we all know and love, that was last updated in 2002 around computer software assurance, in the preamble, it talks about the fact that the amount of effort needs to be commensurate with the risk to the patient and the complexity of the system. So that risk-based approach was baked in when it was originally written in 1999 and last updated in 2002. So 24 years ago, there's a risk-based approach. Again, we need to get our own way as an industry and enable ourselves, give ourselves permission to implement the latest and greatest technologies that will improve patient outcomes ultimately.
Yeah, I like the term. Are they comfortable with use of it? I don't think. I mean, not only are they comfortable, they're actually expecting us to use new technology. That's the whole premise of all the new guidances, and the and Pharma 4.0 and Validation 4.0. So.
Awesome. Thank you both so much. I believe that is all the time we have for questions today. Thank you again, Gilad. Thank you, Dan, for speaking today. Great insights. And thank you to everybody who attended today's webinar. As a reminder, we will be sending the recording following this session. If you'd like to learn more about anything that we discussed during the webinar, you can reach out to Dan or Gilad directly on LinkedIn. I've linked their profiles in the chat, or you can reach out to the Tulip or Expedia team directly. And that is all the time we have for today. So everyone have a great day, and thank you again.
Thank you very much. Thanks, everybody.
Bye-bye.